Today we're going to be talking about electric current. So the objectives of this lesson are: how is electric current produced? How are conductors and insulators different? And how does resistance affect current? So we're going to start out by talking about electric current. Electric current is a continuous flow of electrical charges through a material. We would generally know this as probably just being a wire of some sort. Okay, so it's measured in amps. Amps is named after a French scientist who was one of the first to investigate using electricity. It's, if you put it at the end as a label, it's just a capital A. The number of amps describes the amount of charge flowing past a point in a given second. So this is important to know because certain wires can only hold so many amps at any given time, and you can't overload them or bad things are going to happen. All right, electric current is closely related to an electric circuit because electric circuits are the only way we're able to have a continuous flow of electricity in things like our homes. Our homes are full of electric circuits, and generally we're not thinking about them when we flip on a light switch or whatever. Okay, these are complete unbroken paths that electrical charges can flow through. So think of it kind of like a racetrack. It's just a giant circle, if you will. Okay, these are necessary to produce currents. So you have to have circuits to make currents. So visually, okay, if we have a battery as our electrical source, then we have an electric current flowing through this whole circuit, which is circular in shape, if you will. Okay, so this would be like you flip on the light switch, and then your lamp on your desk turns on, and then that circuit is still completed because there's still electricity flowing out of that light bulb back to the battery. All right, conductors and insulators. These are important to know because there are times when we want electricity to flow easily through things, and there's times when we want electricity to not be able to flow through things. So let's start with conductors. These are materials that electricity flows through easily. Okay, so on the periodic table, these are materials that have electrons, free electrons, that flow easily, and we all know that electrons have a what kind of charge? Negative charge. Good. So they're going to carry those electrical charges. So conductors are good at moving electricity from one place to another. Okay. So examples of these, and obviously there's a lot of examples. Okay, so things like silver, copper, when lots of copper wiring is used, seawater, and gold. All of those are good conductors of electricity. Insulators are the exact opposite of conductors. Sometimes we need materials that aren't able to push electrical charges through very easily, or not at all. Okay, so these are materials on the periodic table where the electrons are bound tightly to the nucleus, so they're not flowing freely, and so those charges are also not flowing freely. Okay, these are important because you might have a copper wire, but if you have electricity flowing through this copper wire, a human can't grab onto it without electrocuting themselves. So most wires, especially ones we use in our home, are covered in some sort of material, usually rubber, that is an insulator, and that electricity that might be flowing through that wire is not going to get to us. Since we, as humans, are good conductors of electricity, we don't want to be electrocuted. So things like rubber, glass, wood, and diamonds. All right, voltage. Voltage is named after Alessandro Volta, who was one of the first to study batteries and electricity. So as with all things in science, if you're one of the first to study something, you get to name something after yourself. So voltage is named after volta. Right. Voltage is by definition the difference in electrical potential energy between two places. So if we go back to when we talked about kinetic and potential energy, if you remember the roller coaster example, okay, kinetic energy is when it's moving, but when it's just sitting still and it's really high off the ground, you have really high potential energy. So from the top of your roller coaster to the very bottom of the roller coaster, there's a huge difference in potential energy from here to here. Okay? So voltage is what causes the flow of electricity to occur. So as with so many things in science, equilibrium is what is desired. Electrical charges want an equal charge everywhere in the circuit. They want it to have an equal charge. But because of voltage, where you have a change in potential energy from one place to another, that's what's causing that electrical flow, that circuit, which is what we want, because that's how you get things like your refrigerator to run, or your phone battery to charge, or the lamp to turn on. That flow from a low area of potential energy to a high area, because the circuit is always trying to reach an equal amount of charge. So circuits are not creating voltage on their own. So you have to have a source. So if you think back to the circuit, the source that caused that change in potential energy with that light and that battery would be the battery. That battery is making that change in potential energy. And then we have what we call resistance. So current also depends on resistance. So your current depends on voltage and resistance. Resistance, by definition, is a measure of how difficult it is for charges to flow through a material. So again, this is important information because lots of different materials or appliances in your home have different resistances. Okay, so a greater resistance means there's less current flowing through it. That would be good if you have something that can't hold all that electricity, or it's not using all that electricity, then you don't want all that electricity flowing into it and maybe starting a fire, versus maybe something else that needs a large amount of electricity. Its resistance is going to be lower so that you can have a greater current flowing through it so it can get the electricity it needs. Okay, this is measured in ohms, which is this little Greek symbol, ohms. So you've probably heard the term path of least resistance. Okay, so this means that electricity wants to flow in the easiest path that it can. So they're going to choose the easier of the paths so it can flow. Okay, so when people get electrocuted, that's because humans are good conductors of electricity, and that you're not being safe around electricity, and now your body has made a very good current and easy current for that electricity, and it's going to choose to flow through you. So we've all seen like birds sitting on electrical wires. They don't get electrocuted because the wire is a much easier path to flow through, so that electricity continues to flow through that wire instead of into the bird. That's not its path of least resistance. There are 4 factors that determine resistance. One of them is the material that the wire is made from. So obviously, if you have something that's an insulator, which we learned earlier is something that electricity doesn't flow through very easily, you're going to get more resistance. Length of the wire. If you have a longer wire, a longer point between A and B, that's going to cause more resistance. diameter of the wire. So diameter, we know, is the area around something. So if you have a thinner wire, that's more resistance because there's less place for those electrical charges to flow through than if you have a big wire. And then the temperature of the wire. So higher temperatures cause more resistance. That's why it's important to keep those things cool.